Friendly, funny.
He's good. He's tough and good, yes.
He's a great mentor. He's a great teacher.
A famous colleague of mine, my mentor, Robert Gallo, defined the passion for scientific research as socially acceptable addiction. The man is an Italian from Milan. I grew up and graduated in Milan. I wanted to be a psychiatrist. Before graduation, I realized that that maybe was not the right moment to do research in mental disease. And there was a time in which all the DNA technology in cancer was being developed. So I switched and I got and trained in hematology and oncology. At the beginning of the 70s, we knew that cancer was a genetic disease, but we did not know what genes were involved in that. Identified genes in the DNA of chicken that were derived from viruses that have generated genes in viruses, and the viruses cause cancer. So in Bethesda at NIH, I cloned the first human proto-oncogenes. It was found to be involved in a genomic alteration called chromosomal translocations that were the hallmark, were present in 100% of a particular type of lymphoma called Burkitt lymphoma. Lymphoma is cancer of B lymphocytes. B lymphocytes are our cells that produce antibodies, so the cells that are deputed to our immunity to fight foreign substances foreign to the bodies, virus, bacteria, any kind of foreign substances.
That there are different genetic lesions in different types of lymphomas. And this is what we are trying to understand here. How is a lymphoma different from another? Which are the genetic lesions that determine one disease or the other? And which can be the putative targeting strategies to affect specifically these genetic lesions?
I think the key points were the discovery of the first human oncogenes and its involvement in lymphoma, and more recently the definition of all the genetic alteration that cause a lymphoma. Again, the discovery, if you wish, that over close to 100 genes need to be altered. And our work also is based on reproducing this genetic alteration in mouse models and showing that what causes lymphoma in human is also causing lymphoma in mouse, and therefore proving the role of each of these alterations.
I think without discovering the causes of the tumors, you cannot develop efficient therapies.
So the future, and the future is close, and what is going on now in research, is instead of using chemotherapy, which is a poison that kills more tumor cells than normal cells, develop more targeted therapy that kill only tumor cells, because they address the mechanisms that generate the tumor rather than being a general poison. For me, an Italian, a European who has spent most of his career in the US, it's always good to be recognized by Europe, and so I was particularly pleasantly surprised. This money will help my team to continue the work that we are doing, and in particular now we have more mutated genes in lymphoma that we can study. The more funds we have, that will allow us to address new questions about this genetics and therefore progress more efficiently in our research. Specifically, we plan to use this money to create 2 new mouse models of lymphoma based on gene alteration that we recently discovered that we believe will be useful to test new therapies. But my hope is that the work that we have done in these 30 years will make it to medicine and oncology textbook, so will remain as a solid discovery in the future, and two, that those discoveries will lead to better diagnosis and treatment. And I think it will happen.